All right, excellent. You are familiar with the main syntax in Python, and that will help you in the next lessons. In this section, we will learn more about the operators that will help us in our work in Python. We will start with comparison operators. We said if we type the equality sign twice, we can verify the left and right side of an equality are equal. Well, if we use an exclamation mark and an equality sign, then we could verify if two sides are not equal. So, it would be false to say 10 is not equal to 10. And it will be true that 10 is not equal to 15. If we use an exclamation mark and equal, and the two sides we are comparing are 10 and 15, we'll obtain true, as we wanted to verify they are not equal. Good. What is next? Greater than and less than. We can use the well-known symbols to test if a value is greater or smaller than another value. Is 100 greater than 50? Yes, it is. Is it smaller? No, it is not. And that's why we get false. That's great. The logic behind checking whether an operand is greater than or equal to and less than or equal to is the same. Don't forget that on the right side of the operand, we are not limited to providing only one number, like 10. We could insert an expression, like 10 plus 10. So is 15 greater than or equal to 10 plus 10? No. Is 15 less than or equal to 10 plus 5? Well, that is true. Great! This covers everything we can possibly say about comparison operators. Now, let's see what is intended with the expression logical operators, also known as Boolean operators. Briefly, the logical operators in Python are the words not, and or. They compare a certain amount of statements and return Boolean values, true or false, hence their second name, Boolean operators. Let's start by providing an example with and. And checks whether the two statements around it are true. Let's use only the Boolean values true and false for now. True and true will result in true, while true and false gives an answer, false. False and false will naturally bring us to false. Okay. Or checks whether at least one of the two statements is true. Hence, false or false will come back as a false, whilst true or true will return true. In this cell, true or false will return true. The order in which we have the two statements does not matter, so false or true will still result in true as well. The way not functions is it leads to the opposite of the given statement. Not true leads to false. Not false leads to true. Let's see a slightly different example. The idea is to show you in this cell that the Boolean operators can be applied not only to Boolean values. The statement 3 greater than 5 is false, while 10 less than or equal to 20 is true. False and true entails false. And this is what we obtained. Good. The fun starts when you combine these logical operators. In these occasions, you must respect the order of importance of these three operators. It is not comes first, then we have and finally or. The examples in these three cells will help you get the right intuition. In the command true and not true, we should first consider what the operator not will do. It will be applied to the value true, and not true means false. Therefore, what's written in this cell must be interpreted as true and false. Now, the remaining operator and can be applied. True and false leads us to false. The answer is correct. False. Let's do an example with all three Boolean operators. False or not true and true. False or not true and true logically is the same as false or false and true. Because before anything else, not true must be read as false. Then and has an advantage over or. This is why we will concentrate on the phrase false and true. Its outcome is false. We are now left with false or false. Both values are false, which always leads to false. As expected, false. To solidify the concept, let's go through another similar example. True and not true or true is the same as true and false or true, because initially, not mattered most. Now, and will convert true and false to false. Now, we can think about the remaining false or true, because the or operator needs at least one true statement to return true. Our result after running this cell will be true. Great! Let's see what identity operators are about. The identity operators are the words is and is not. They function similar to the double equality sign and the exclamation mark and equality sign we saw earlier. Let's illustrate their application with the following examples. If we say 5 is 6, we'll immediately understand it is false. The same as if we wrote it like this, with the double equality sign. If we said 5 is not 6, that'd be true. And it will be the same as if we wrote 5 exclamation mark equals 6. Great! You have learned a lot about operators in Python and about its syntax. It is the right moment to dive into something more interesting. Starting from our next lesson, we'll deal with a topic that is a big part of a programmer's everyday life: conditionals. You are prepared to dig deeper, so do the exercises and see you in our next video. Thank you for watching. In the previous lectures, you saw how you can assign different values to a variable. In this lecture, you will see values act as the most basic or primitive data elements necessary to form not only variables, but any expressions. A prominent example of conditional statements in Python is the if statement. What you can use it for is intuitive, but it is very important to learn the syntax. Think of the following. If 5 equals 15 divided by 3, then print hooray. First, don't forget we should use the double equality sign here, because we are checking whether 5 is equal to 15 divided by 3, and we are not assigning the value of 15 divided by 3 to be 5. 5 is not a variable name. It is a number. Good. Now, it is crucial to place a colon. The colon will tell the computer what to do if the condition we just wrote has been satisfied. For achieving good legibility, we advise you to write the print statement on a new line. Please remember, it should be indented. Otherwise, you will run into an error. All right. Now this should work correctly. Yes, 5 is equal to 15 divided by 3. Hooray! Will it work if we check for 5 being equal to 18 divided by 3? It is not supposed to, since 5 differs from 6. We got nothing, because we have not told the machine what to do if the provided condition is not satisfied. So, there is no reason for the machine to print out hooray. The graph could help you imagine the process of the conditionals. Before it displays the outcome of the operation, the machine follows these logical steps. If the conditional code is not to be executed because of the if condition is not true, Our program will directly lead us to some other output, or, as it is in this case, to nothing. After any of the two situations, the machine will go to the next black point and will progress from there on. Let's try with an inequality sign, which can be written with an exclamation mark and an equal sign. Isn't 5 different from 3 times 6? Yes, it is. It is true that it is different. Hence, we have hooray as an output. This was a brief introduction to if statements. This logic will help you proceed to the next lecture, where we will complicate things a little bit, but not too much. Thank you for watching. Let's assign the value of 1 to x. We can ask the computer to display case 1 if x is greater than 3, and case 2 if it is less than or equal to 3. Okay, we could write two if statements one after the other. Let's see if we get the correct outcome. Yes, we are in case 2. There is a shorter and better way to express ourselves here. In the second part, instead of saying if x is smaller than or equal to 3, we could write directly else and insert a colon. Else will tell the computer to execute the successive command in all other cases. In our little program, that would mean in all cases when x is not greater than 3. That translates into when x is less than or equal to 3. Let's verify if what we did was correct. Bingo! Case number 2.
This picture adds up to the one we saw in the previous lesson. Instead of leading to no output, if the condition is false, we will get to an else code. In our case, this is the print function with the string case2 as an argument, written in parentheses. Regardless of whether the initial condition is satisfied, we will get to the endpoint. So the computer has concluded the entire operation and is ready to execute a new one. Wonderful! Now, please allow me to share 2 notes on the subject. Don't fall into the trap of organizing your code on a whim. There is a strict manner to do that, and indentation plays a key role again. Should you put the else keyword just underneath the first print word, nothing will happen. Remember to place the if and the else keywords on the same vertical line. This is the right moment to introduce you to the notion of blocks of code. The if statement, meaning the condition plus the relevant print function, forms the first block of code. The entire else statement forms another block of code on its own. Therefore, in a long sheet with much code, you'll have a whole lot of blocks. And larger programs are constructed on a block-by-block basis.
We are ready to look at elif statements. Thanks, and see you in the next video. In this lesson, we'll learn an elegant way of adding a second if statement to one of our expressions. This is done with the help of the elif keyword, as shown in this example. If y is not greater than 5, the computer will think, else if y is less than 5, written elif y is less than 5. Then I will print out less. And the else statement follows as a tell with the respective block that says return equal. Let's confirm we wrote the code correctly. We can print out the compare to 5 function with a value of y equal to 10 in the following way. Then we'll expect to see a statement that says greater because 10 is greater than 5. Correct? Okay, perfect. What if we carry out this operation for the number 2? The machine tells us that 2 is less than 5, and that's what we expected. To obtain the third outcome, we must compare the number 5 with a number that is not greater or smaller than 5. This will happen only if the argument of the function is 5, right? Shall we try this one? Great! We obtained equal as expected. Know that you can add as many elif statements as you need. Let's provide an example. If y is less than 0, the string negative should be displayed. I will place the block between the if and the other elif statement. Let's see what happens. The function with an argument of -3 shows negative, just as it should. Let me just control whether our little program will run properly if I asked it to compare to 5 a value that lies in the range between 0 and 5, say 3. Yes, we see less, so everything is okay. A very important detail you should try to remember is the computer always reads your commands from top to bottom. Regardless of the speed at which it works, it executes only one command at a time. Scientifically speaking, the instructions we give to the machine are part of a control flow. This is something like the flow of the logical thought of the computer, the way the computer thinks, step by step, executing the steps in a rigid order. When it works with a conditional statement, the computer's task will be to execute a specific command once a certain condition has been satisfied. It will read your commands from the if statement at the top, through the elif statements in the middle, to the else statement at the end. The first moment the machine finds a satisfied condition, it will print the respective output and will execute no other part of the code from this conditional. In our example, if the first statement is correct, we will see the corresponding output number 1, which is printing the string greater. The computer will disregard the elif and the else statements and will proceed with the rest of the code. If the first statement is not correct, we will move forward, and the computer will check whether our second statement is true. If yes, we will see output number 2, which is printing the string negative. If not, we will get to statement number 3, and so on until the computer finds a satisfactory outcome to print out. Now, I will switch the order of the two elif statements to prove that the order of instructions matters. Okay? Let me print compare to 5 of -3. Ha! Instead of negative, we obtained less. This is how the computer reasons. Assume y equals -3. Print out greater if y is greater than 5. Is it greater than 5? No. So the computer continues and checks if there are any other statements in our code. Given we have other statements, it moves forward. So is y less than 5? Yes, it is. At this moment, the computer thinks, lovely, I got it. My number is less than 5. I satisfy what my programmer asked me to do. I print out less, and I am fine. And the machine stops there and does not execute a single letter of the code that follows in this block. The fact that you examine the cases when y is less than 0 or equal precisely to 5 have no application. They become useless. Whether you ask for the output of -3 or 3, you will still have to be satisfied with the less label. You found this interesting, didn't you? Stay focused for the next lecture, when we will share something more about computational logic. Thank you for watching. You probably noticed we talked about Boolean values a few times. Here, we would like to provide a short video that aims to explain their application. Let x be equal to 2. What you see next is the following if-else construction. If the value of the x variable is greater than 4, print out correct. In all other cases, print incorrect. So, which is the Boolean element we have in this computational logic? Basically, after you insert your if statement, the computer will attach a Boolean value to it. Depending on the value of its outcome, true or false, it will produce one of the suggested outputs, correct or incorrect. If the first statement is true, that is, if x is greater than 4, the machine will print the corresponding statement correct. Else, which means if the statement x greater than 4 is untrue, or more precisely, false, the statement incorrect will be printed. From a certain perspective, everything in a computer system is Boolean, comprising sequences of zeros and ones, false and true. This is why we are paying attention to the Boolean value. It helps us understand general computational logic and the way conditionals work in Python. Okay, excellent. We can wrap it up here. This wasn't an easy section, right? But you learned a lot and are making a great progress. Now you know more about conditionals in Python, and you understand the control flow of if, elif, and else statements. In addition, you saw once more complying with the Pythonic syntax is crucial for the execution of your code. Where you type the colon sign and indentation matters. Last, you saw the order in which you declare your commands leads to a specific outcome. If you change the order of your commands, the outcome could change, and this may take you to undesired results. Wonderful! In our next section, we'll dive into the world of Python functions. See you there, and thanks for watching.